Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from the section Linear Algebra. And this is a multiple choice question for 2 marks, and the question number is 16. This question is suitable for all these examinations. In particular, this is very much suitable for JL, DL, TG set and AP set examinations. Right. The given question is, let A be a 6 by 5 matrix with the entries from the field of real numbers, and B be a 5 by 4 matrix with the entries from the real field. Consider the following 2 statements. Statement P: for all such non-zero matrices A and B, there is a non-zero matrix Z such that the product AZB is the 6 by 4 zero matrix. Statement Q: for all such non-zero matrices A and B, there is a non-zero matrix capital Y such that the product BYA is the 5 by 5 zero matrix. Which of the following holds? We are given 4 options. Option A, both P and Q are true. Option B, P is true but Q is false. Option C, P is false but Q is true. Option D, both P and Q are false. Right. Let's now discuss the solution of the problem in detail. We are given A is a 6 by 5 real matrix. It is a 6 by 5 real matrix. B is a 5 by 4 real matrix. Right. Let's call the statement P. For all such non-zero matrices A and B, such means such 6 by 5 matrix A and 5 by 4 real matrix B, there is a non-zero matrix Z of suitable order such that AZB is a 6 by 4 matrix. So, let A and B be any 2 non-zero matrices of the above said dimensions. A is 6 by 5, B is 5 by 4. For the product AZB to be defined as a 6 by 4 matrix, AZB is 6 by 4, A is 6 by 5, B is 5 by 4, and what should be the Z? Z should be 5 by 5. Then it will be 6 by 5, Z is multiplied by 5 by 5, multiplied by 5 by 4. The outcome AZB will be 6 by 4 matrix. Right. Now, define a linear transformation T from the product AZB. AZB means M 5 by 5 over R. It is the space, vector space of all 5 by 5 real matrices to Z is Z dimension, Z the outcome is AZB is 6 by 4. Therefore, you take the space of vector space of all 6 by 4 matrices over real entries. Then Z comes from M 5 by 5 from R and gets into AZB, which is a 6 by 4 matrix, that is, it goes into M 6 by 4 over R as AZB. Right. Now, if the statement P is true, then we need to show that there exists a non-zero matrix Z such that T of Z is equal to 0. That means this fellow Z must be in the kernel of T. That is, the kernel of T is non-trivial, because we want the existence of a non-zero matrix Z such that T of Z is equal to 0. That means the kernel of T is non-trivial. We use the Rank-Nullity Theorem. Rank of T plus nullity of T is equal to the dimension of the domain space. The domain space is M 5 by 5 over R. What is the dimension? The dimension is 5 into 5, that's equal to 25. Right. And what could be the rank? What could be the rank? The rank will not exceed the dimension of the codomain space. That is, the rank of T is less than or equal to the dimension of the codomain space, that is M 6 by 4 over R. The dimension of vector space of all 6 by 4 real matrices is 6 into 4, that is 24. Therefore, nullity of T is the rank of T, the 25 minus rank of T. 25 minus rank of T is less than or equal to 24. Therefore, 25 minus rank of T is greater than or equal to 25 minus 24, that is equal to 1. Thus, nullity of T is 1, tells you the null space of T is non-trivial. That is the kernel of null space and kernel are one and the same. Kernel of T contains a non-zero matrix Z. That this implies there exists a non-zero matrix Z such that AZB is equal to 0. Thus, the statement P is true. Right. We move to the option Q in the next slide. Option Q. For all such non-zero matrices A and B, such means of the above dimensions A and B, there is a non-zero matrix Y such that BYA is the 5 by 5 zero matrix. Let A and B be any two non-zero matrices of the above said dimensions. A is of 6 by 5 order, B is of 5 by 4 order. Now, for the product BYA to be defined as 5 by 5 matrix, what should be the dimension, that is the number of rows and number of columns of Y? It should be 4 by 6. 4 by 6. Why? B is 5 by 4 into Y is 4 by 6 into A is 6 by 5. Then the outcome is BYA is 5 by 5 matrix. Now, this time, if this statement Q is true, then we need to show that there exists a non-zero matrix Y such that BYA is equal to 0. Now, define a linear transformation T from the space of all 4 by 6 matrices over R, M 4 by 6 R to M 4 by 5 R. This is also a vector space defined by T of Y, and Y is a 4 by 6 matrix and is equal to YA. YA will be Y is 4 by 6, A is 6 by 5, and the outcome is 4 by 5. So, correct. So, this is a linear transformation T, that is from the vector space of 4 by 6 matrices with real entries into the vector space of all 4 by 5 matrices with entries from R, and defined by T of Y is equal to YA. We use Rank-Nullity Theorem. The rank of T plus nullity of T is equal to dimension of the domain space. The dimension of the domain space is M4 by 6R, that is the dimension is 24. What will be the rank? The rank of T will not exceed the dimension of the codomain space. Therefore, the rank of T is less than or equal to the dimension of the codomain space, that is M4 by 5R, and its dimension is 20. So, the rank of T cannot exceed 20. Therefore, rank of T is less than or equal to 20. Therefore, the nullity of T will be 24 minus rank of T, and that is greater than or equal to 24 minus 20, that is 4. Yes. That is the null space is non-trivial. That means the kernel of T is non-trivial. It contains a non-zero matrix Y, because the nullity of T is 4. So there exists a non-zero matrix Y such that YA is equal to 0. For any such non-zero matrix Y, we have BYA, the product is equal to B into YA, YA is 0. So B into 0 is 0. So thus for every non-zero matrices A and B, there is a non-zero matrix Y such that BYA is 0. Thus the statement Q is also true. So the answer to this question is both the options P and Q are true. That is your answer. That is in the option A. The answer is option A. That is the detailed discussion of the solution of this problem. And this problem is definitely a good question and suitable for JL, DL, TG set, AP set examinations. In a way, this is also suitable for the remaining 2 examinations, that is CSIR NET and GATE also. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes. I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.